Welcome, everybody, to the American Space Museum. I'm Marquette, and we're so glad you're with us to stay curious with Mikey Haddad. Welcome,
Thank you.
Mikey.
Good to be back, Mark.
He's a NASA systems engineer for 32 years and is a payload expert. That's why we call it Payloads with Mikey. Got Marty Winkle working the Stream Labs, and I don't have our picture on our monitor here, Marty, but sorry we're a little bit late. We had a technical problem. You never know when you push the buttons what's going to happen here. But Mikey, we're so glad that you're with us and wanting to share with Stay Curious listeners your in-depth knowledge about space labs particularly, but all the payloads. And you wrote a book about it right here with David Saylor. David Saller. David Shaler, okay, who's in England. We talked to him with Mikey back in May, or maybe it was even April. But there's your book on payloads, specifically Space Lab. And what are we going to talk about today?
We're going to talk about one of the little-known payloads that flew on STS-7, OSTA-2. It was basically our first payload that Level 4 actually did the complete integration and testing on.
And that's important because this is the 7th mission ever launched of the 135 30-year program. Of course, Sally Ride was on that in 1983, commanded by the great Bob Crippen, who had 4 rookies on there with him.
That's something.
Isn't that amazing? Yeah. Early in our space shuttle history there. Mikey, tell us a little bit about yourself. Where'd you grow up and how'd you get in this career?
I actually grew up in Ohio, but then moved to Titusville, Florida when I was 9. Was a space nut ever since I could remember. Found out we were moving to Titusville, which is a little city right across the water from Kennedy Space Center, and I had gone to heaven because that's where I wanted to be. And so I just took classes and learned about engineering, and went to UCF, graduated there, and went to work at the Space Center. Actually co-opted at the Space Center for a while, and then actually when I graduated full time, went out there, and 32 years later, retired in December 2011. But yeah, it was basically background mechanical engineering. Worked for NASA for all those years and at Kennedy Space Center. Did some details at Johnson Space Center and other places, but mostly at Kennedy.
University of Central Florida. What year was that you graduated?
I graduated in 1982, April, and I went to work 3 weeks later at Kennedy Space Center.
40 years ago.
Yep.
It looks a lot different now, that campus, doesn't it, Mikey?
Oh, gosh. Yes, it looked a lot different. There wasn't nearly as many students when I went there. In fact, when I went there, it was actually Florida Technological University. They changed their name about halfway through when I was going to college.
And of course, we've got a beautiful shuttle on the pad here. As you're familiar with seeing these scenes up there in your career, we had an interesting show with Mikey about the first space lab and the animals that they had to put in the carriers. In the space lab was in the cargo bay at the pad, vertical. You want to check that one out, and we'll talk more about that as our programs go along with Mikey here.
We did them many times. That was done.
We want to remind everybody just real quick, Mikey, Saturday is our space memorabilia auction, the 20th auction that Chuck Jeffrey, our collections analyst and chief operating officer of the museum, has put on. We got some awesome memorabilia on there, and we got a program with Chuck tomorrow that you're going to enjoy about all the different 400 lots we have Saturday online or here at the American Space Museum.
That's great.
Enjoy that. And Mikey, we enjoy talking about the shuttles of every month, 11 shuttles of June up there, and we're talking about the 1, 2, 3, 4, 5, the 6th launched in the month of June. STS-7 there, which was the C for Challenger. And a lot of great missions there. What's interesting about June, Mikey, is we saw the last mission to the Russian Mir space station was launched on the 2nd of June, and the first was launched on the 27th of June. Those are 6 years apart. Our great Mir program that we learned so much about living in space from the Russians. But we're going to talk about, as soon as I shut up, Mikey's going to talk about Challenger. John Fabian was on that. Rick Hauk was the rookie pilot. Of course, Sally Ride and Norm Thagard. And Sally Ride, the first American woman to go to space, the 3rd woman overall behind 2 Russians. she stole the thunder, but she was an awesome person and would never make appearances without her entire crew because she didn't want not be singled out. She knew it was a team effort. And there they are in space there. Uh, and Bob Crippen, just another amazing historical astronaut of the annuals in there.
Oh yeah.
So Mikey, I'm gonna let you take the button there, so you
Okay.
can. And there's your advanced button right there.
In the middle there.
So Mikey Haddad, take us away with the payload of STS-7.
Okay, make sure I
It
do
didn't
this
get
right.
much notoriety. Yep.
First one, okay. All right, what we're going to do here is we'll start out. This is kind of, again, we talked about this earlier. It's a structure called an MPES. Again, I won't go through the acronym, but kind of where we get these structures. And I want to particularly talk about this one because I'm showing the primary and secondary trunnions and keel. These were the attachment points that how this structure was attached to the shuttle, okay, was via all these points. Well, we got this structure, those trunnions are off. So it was a basic structure we got for STS-7. It was one of the first ones we did. And that was kind of my job, was putting these trunnions and keel on. That was my first level 4 flight hardware assignment, was putting those trunnions
Did
on.
you weld those or?
No, they're actually went on by bolts.
By
a whole bunch of bolts,
okay.
yeah. And I'll talk a little bit about, I guess I could talk about it now. Yeah, we had some interesting times because the bolts went down, and there was actually a cotter pin. You had to stick your hand underneath, and we'll see a picture of it later. Well, that was a very interesting and very difficult task. In fact, the tech I was working with, called Walt Preston, he was one of our best techs we had for the SICE contract, Boeing SICE contract. He cut his hands up all, and you know, we had the gloves on, so he's pulling his gloves off. He had to keep changing his gloves out. He pulls his hand out one time, his finger is bleeding. He cut the cotter pin on his finger, and so we got to go, you know, take care of that. He goes, no, he says, he says, we got a job to do. I'll be right back. He comes back later, blood's done, he's all cleaned up. He super glued his finger together. Right. He says he's done that many times. He says, I'll just do that and we'll continue to work. And basically, so it was an interesting job putting these trunnions and keel on. It was the first time we'd done it. Okay, so this is the basic structure we got.
Became a routine, though.
It became a routine.
Putting in the payload bay.
Yeah, it was kind of a structure for smaller type experiments. And so this is the basic structure we had. And this is what we were trying to integrate to, was basically a large box, MIA, and mouse. And I'm not going to try to go ahead. You can see their acronyms, they're German, so we're not going to try to pronounce that.
I won't hold you to them, okay.
But basically, this was our assignment, was to take that basic structure and add these components and cabling and a number of other items to that for the complement. You can see again the trunnions and that on there. So that was basically our job, was doing that, was integrating this whole thing together and getting it ready for flight. So that's
first, and this is one of the very first times I want to emphasize,
yes,
folks.
This is
the 7th flight, 1983. All right, the first flight was April 81. So there's still a lot of learning going on here, and each flight that's new, where they're doing something new, a lot of eyes on this, right, Mikey?
Yeah, it was a lot of first timers on first time things done here because it was one of the first to fly in the shuttle. So it was a learning curve. We were trying to learn as we went. So this is basically what it was supposed to look like. So that was the integrated payload that would fly. Okay, so this is kind of a picture of the MPES and a yellow structure. This is the transportation structure that it came in on. And then, and basically this is, you know, how it came to the Kennedy Space Center. But then how do you handle it once you get it off the truck, get it into the building? It's a clean room. And so you see forklifts down at the bottom. But at this time, we didn't really have a forklift that could handle the weight of this in the clean room, so we had to do basically a crane ops. Now, we always try to minimize crane ops because it's a hazardous operation. And the way we did it here is this is a close-up of a yellow structure. Basically what it was those holes you see in the top, there's a beam that went across to lift that whole structure. That yellow structure, the MPES, kind of the MPES went along for a ride. And that's how we handled it and moved it around the O&C. The operations checkout building was by crane. Again, crane ops is a hazardous procedure, a lot of people involved. So we would try to, as time went on, to tell people, just put wheels on these things. Okay, put wheels on them, and we can wheel them where we need to, instead of having to do a crane to get it from one area of the building to the other. So that was just, I wanted to show this. Again, this one actually shows the trunnions on.
Did they listen to you?
Yes, sir, yeah.
Okay.
Yeah, they started put wheels on and other ways of handling it. Now, this picture actually shows the trunnions on there, but they weren't on when we got this structure. So basically, we had to take this structure and then put the trunnions on. And once we put the trunnions on, then we can put it in one of these blue structures. This is another payload that flew later called OSTA-1, but I wanted to show the blue structure that it went from this yellow structure. Trunnions went on, then went into this blue structure, and this blue structure represented the shuttle bay, basically. And so the attachment points between the payload and that blue structure are the trunnions that we talked about. Of course, you got to put the trunnions on first to do that. So that's kind of wanted to show kind of how that first process went and how we got the thing just into the blue stand. Okay. All right. Next one here. Whoops. Let me go back. Okay. So what we have here is for those experiments, the mouse, the one that looked like the cans, these were the principal investigators in an offline lab that were prepping those cans before they turned them over to us for flight. So we basically, they made sure everything inside was operational before they turned it over to us to install. Now, one thing interesting about this picture is they came in and said, well, we needed a crane. There's no crane in this room. So if you look in the back there, our one engineer, Frank Valdez, who was the one of the lead mechanical engineers, the facility people, Virginia Whitehead, a lot of people maybe know Virginia, she was an LSSM, worked to basically put that crane you see in the back of the room. They had to, hey, can the structure handle the lifting? How do we even put a crane in here? And so that was one of the things that came up. Another one, learn as you go, learn as you go. So they had to install this crane basically in the room to complete their operation. And so these are some of the PIs, the German PIs for those mouse cans. Okay, now this is taking one of the cans and actually doing what's called weight and CG. We needed to make sure the weight and the weight of it and the center of gravity was in the correct location.
Weight and C. So weight
and center of gravity.
Mass and the center of gravity. That's interesting.
Yeah. Now to do this, we actually, the team here, Herb Lindenhart on the right, Chris Medor and Bruce Birch, Bruce Birch was one of the guys that went down in that. He basically was the guy that went down on the hook when we talked about Spacelab 3 earlier. They actually had test simulations. They had things that would simulate so they can train on how to do weight and CG before the actual flight hardware. Before actually doing the flight hardware. And so they trained on that, and then this is the actual flight can, the flight mouse going through weight and center gravity test. And this is, again, we did in level 4 to prep it for installation.
Nice photographs. Who typically would take these photographs?
We had the professional photographers. I think at the time it was Technicolor. They would take these professional photographers. We photographed everything because
you always had someone with a camera photographing your work. Is that right?
Yes, sir. And then we a lot of times we'd video crane ops as well.
Film days too, back in 1980.
Yeah, this is all good film. Yeah. Okay. This next picture, this actually shows installation of the can onto the MPES. Down in the lower right is Frank Valdez. He's a mechanical engineer that was responsible in charge of the job. Jay Smithy, you kind of see his head there. He helped get the can in, and then another technician up at the top on the scaffolding. A couple things about this picture. You'll see the big box, the Me, is already installed, and 2 of the other cans are installed. So this is basically mouse B going on. Down in the very center, very lower part of the picture, you can see there's the trunnion with all those bolts. That's the primary trunnion. You had 2 primary trunnions, 2 secondary. Those are the trunnions basically I installed. So putting all those bolts in for each trunnion. And then there was one huge bolt that was actually about 700 foot-pound torque. And of course, that was before we had a torque multiplier. So we got this really long bar to be able to torque those things up to 700 foot-pounds. One other thing here to note is the scaffolding. We're probably 20, 30 feet up in the air here to be able to get access to all this stuff. So they were working at high heights.
And you're in the payload bay of Challenger.
No, actually here we're in the operations and checkout building down in the west end of the operations and checkout building. This is us prepping all this hardware to go out to the orbiter, go out to the shuttle. And they also did testing right here. There was a local rack we basically connected up to make sure once we put all this together and cabled everything up that it all worked. So this is basically the flight hardware we were integrated for STS-7. Again, the first payload for us. Now what I wanted to show here was back then we actually had to integrate with payloads that flew in a vertical orientation, which is another building called the Vertical Processing Facility, which is kind of in the middle left.
See that, Marty, with the arrow?
It's over where it says RTG storage building. Right next to that is called the Vertical Processing Facility. Okay, and so we were in the operations checkout building. You kind of see in the center. That's where we did all our work.
RTG.
Okay, yeah, and then there you go. That's where we started out with the payload. Okay, the other 3 elements, the 2 satellites and the SPAs that would fly together with OSTA-2, were being assembled and tested in the Vertical Processing Facility. Okay. So we have to get our payload, which is horizontal, into a vertical orientation. So we went into the canister, the large payload canister, And at that time, there was no way to rotate the canister except take it to the VAB. So that's why I wanted to show this picture. We had to go out the ONC all the way to the north part of the Space Center, rotate the canister, bring it all the way back to the south part of this, into the VPF to be integrated with the rest of the payloads. Okay, so that went on until 1993 until they built the canister rotation facility, which is right there. You got it. Yep. And so that basically what we do, we go from the ONC to the canister rotation facility to the VPF. So basically, it's a lot shorter trip. Really save time. Okay, this is a picture of the canister being rotated in the VAB. The transporter's on the bottom. Okay, this is a picture of the VPF that doesn't exist anymore. This building actually doesn't exist anymore. It was torn down. But that front part is an airlock. The big section is basically the high bays. Okay. And this is a breakdown of what it looked like inside the airlock, the high bays, and then the two cells. And I want to notice the east cell there was where we did STS-7. Okay. And this is a picture inside there showing the two satellites kind of in the bottom behind the structures. And up at the top, you see the spas, that white thing. That's the spas one. Our payload fit in between all those, in between that white structure and the satellites. So here's the three of them being integrated. Our payload's coming in the canister by itself to be integrated with these other three payloads, okay? And this is kind of what it looks like once we went into the canister. The two satellites on the bottom, our payload is the third one, and then the SPAS, which is the deployable that flew on top.
Now,
yes, sir.
In 1984, 83, I mean, when STS-7 was launched, the emphasis was this was a space truck. So single stick rockets, forget about it. We're going to take everything to space in our cargo bay there.
Yes, sir.
Which you see two satellites, the top of them in there. And that's what this mission was most important for they did a Telsat for Canada and Palapo B for Indonesia. Very important communication satellites back in 1984.
Yep.
And as you were going along with this, did you have to do certain things or not do certain things to make the Canadians and Indonesians happy with their satellites?
Well, with us at this time, we weren't working these payloads. These three payloads weren't something that we in Level 4 in the Spacelab group were working at the time. There were other payload people that worked on that, yes, sir. But we did not. No, I did not for this specific mission. Other missions.
Well, I guess I'm asking about time constraints. Was there like, hey, you can't get in there because they're working on the satellites, or?
Oh, sure. Oh, yes, sir.
So that's a whole other coordination of maximize your time.
Yes, sir. Yeah. In fact, that's all planned ahead of time, 2 to 3 years usually before the hardware arrives at Canada.
Really?
You plan the whole orchestra, how things happen, when they happen, so there's no interference. Is exactly what you're talking about. You want to make sure that, hey, you're doing this test. Well, we're supposed to come in on a day. No, you don't want to do that. And of course, you plan that. Well, as you start in the operation, things change. Operations take longer. You have problems. So every day, basically, you have to rethink that. How do I do all this work and keep everybody happy? And that's done basically as we did that every day. Because things would change, schedule would change, hardware wouldn't work, stuff would be coming late. We start testing it wouldn't work. What do you do? And so basically the schedule.
What do you do? Who do you call and say, hey, our test just failed. We need to schedule more time.
That's exactly what we do. We have morning meetings every morning, or we would just get on the horn and say, hey, we got a problem here. We can't do the canister ops tomorrow because we're still testing the payload. Well, okay, how long? We'll say 2 days. And so you change the schedule. Well, you got your launch out there. It's not going to move.
Yeah.
And so as work kept coming in, we kind of get scrunch. And that's why we worked those long hours. Is launch was fixed. We had to fix those problems before we launched.
All right.
Okay.
Next slide.
Okay, next slide. Okay, so what this is basically the canister going down the road in a vertical orientation. This is heading to the VAB. And it's kind of a unique photo because you see there's an animal crossing the road there, which is, I think that's a bobcat.
A bobcat. We just did a program with Triple T on Friday. You want to catch about critters out on Kennedy Space Center in Cape Canaveral. We had alligators. We had what did we have? Deer, tortoises,
wild boar,
armadillos. We didn't have a
snakes.
bobcat though. We'll add that to our pictures there, Marty. That bobcat running across there.
That's kind of a unique photo.
And of course, all the roads around out there at the complex, we're just sitting 10 miles from it. Here where we're sitting inside of our studio, inside our American Space Museum. It's not unusual to see a lot of activity going on, like a payload just trucking down the road, right?
Yep, looking like this thing coming down the road. Oh, there goes another payload to the pad. Okay, again, this is early in the program. Okay, so this is the launch pad. You'll see the canister off to the kind of the left there with the orange tubing coming up, and it's being lifted up into the payload changeout room, which is to the right there. And of course, you see the shuttle to the left. Now, inside that payload changeout room, we had what's called a payload ground handling mechanism, PGM, we called it for short.
PGM.
That's what removed the payloads from this canister, pulled them into that room. Then this whole structure would rotate around to the shuttle, and then you do the opposite. PGM would then remove it take it from the room and install it in the shuttle for flight. Boom, we're good to go. And then we're basically ready for launch.
So this whole rotating service structure, they call it, moves around to cover up the shuttle just exactly where it matches that PGM is with the payload bay. And
those
this is something Artemis doesn't have on its pad.
No.
The Apollo and had a structure to cover it up. Our SLS rocket does not. It's completely exposed to the elements.
Yeah, that was kind of how we did it back then. And that's how payloads would be installed to the launch pad.
Beautiful picture.
Yeah, it is. There's so much there. The mobile launch platform, the shuttle, the rotating service trucker back, the payload canister being lifted into place.
White room is connected to the hatch up there at the top.
Okay, so then once we're in there, okay, this is actually just a graphic of the payload handling PGM, I'll call it for short. And it was actually hung from the crane, from the ceiling on rails. So this whole thing moved on the rails, and it's kind of in the center there were hooks. These hooks came in and grabbed the payload, pulled it out of the canister. Okay, the doors would close, the canister would go away. We'd rotate the RSS around to the shuttle. The shuttle doors would open up, and this PGM then would do the opposite. It would move forward with those hooks and install the hardware in the shuttle. And to note, the places in the canister is exactly where it would go in the shuttle. So that's why we placed those things specifically in those, predetermined locations in the canister, so it matched exactly, with where it went in the shuttle. So I just wanted to show this is the.
And all this pre-planned years in advance, hundreds of people involved. You've got, with these experiments, people's doctorate theses. You've got all kinds of am I right? I mean, there's a lot riding on the line.
Some of these principal investigators, we call them PIs, spend their whole career on one mission that flew on the shuttle, a 10, maybe 12-day mission. You spend a whole decade of your life preparing for a 10-day mission, 12-day mission.
Wow.
They were that dedicated. And then, of course, when the science came back, they could spend decades, reviewing the science. So, yes, sir, that's exactly what happened. A lot of these principal investigators, some of them flew multiple times, but some of them, we integrated a lot with them because that was, we were handling their hardware. It was their baby. They turned their baby over to us. These kids out of college handling multi-million-dollar pieces of hardware that the scientists worked a decade on. Some of them weren't very happy with us basically being responsible for that, but that was our job. Yep. Okay, now this is actually a really cool picture. This is looking down in the payload, basically the payload changeout room. The PGM is to the bottom of the picture.
Challenger's on the pad vertical. You're looking into the payload bay.
You're looking down vertical, down into the payload bay. Challenger is up at the top, and the payloads are in the center. So this is kind of what it looked like once the payloads were installed in the shuttle with the PGM for that mission. This is kind of a really neat photo. Yeah, it's kind of a lot there. It's kind of a busy photo, but it shows
light there for.
Yeah, it kind of shows the whole element. Basically, again, this is how we stalled in the shuttle, and then hey, we're ready to go do some testing, and off we go into space. Okay, and then the next picture, that's us in space. You can see the satellites are the two satellites on the bottom. We're in the middle. Okay, now where's the fourth one? It's missing from the cargo bay, right? Well, that's what's taking the photograph. SPOS 1 was a deployable. It basically was grabbed by the arm and then deployed in space and flew around the shuttle. And this is a photograph from that SPOS 1 payload of the shuttle.
Shuttle Pallet Satellite, number 1. Performed research on forming metal alloys in microgravity and using a remote sensing scanner.
Yeah. Really cool picture.
Well, hope you're enjoying our conversation with Mikey Haddad here. Meldano Fernandez Lopez is. Glad that you are. Robert Law is up in Dundee, Scotland.
Wow.
Dave Stange, thank you for watching. Pam Shivik, one of our big followers there. Appreciate that. And we got Tom and Mark Usiak watching us today from Lancaster, Pennsylvania. Mikey.
Excellent.
Yes, these are the seminal images of this STS-7 mission.
Mm-hmm.
The first time a shuttle was photographed orbiting the Earth by a satellite that that moved around the orbiter and took all these great photographs. There's the payload bay arm there that Sally Ride was operating.
They try to put it in the shape of a 7 for STS-7.
Yes, yeah, put it in shape of a 7 there. Yep, for STS-7.
And this payload was retrieved and brought back to Earth. So bottom line, the 2 satellites were deployed that you see on the bottom. Those were deployed into space. The structures came back, our payload came back, and the spas came back. One other picture I wanted to show here was really cool. This is a picture of the OMS firing for STS-7. Really a cool picture. The Earth is, of course, on the top.
And your payload's in the foreground there.
Yep. Yeah, you see the big Mia box kind of sticking up above everything. Yeah. That was our payload. Yep.
Tell us about what those thrusters are.
The OMS, basically, that's kind of helped orient the shuttle. Basically, it would be used for a lot of time altitude changes, different changes in the orientation of the shuttle. You had RCS jets, which kind of did the small movements. The OMS were for large, sometimes orbit change or altitude changes, those kind of things.
And for reentry, they moved the orbiter backwards in its orbit and fired those to slow it down.
Yep, those were the main engines to get us home. We had to fire the OMS to get home. Yes,
beautiful, beautiful picture.
Yeah, that's kind of, I went through that in there. I thought that was a cool picture. And then the last one here, this is basically our site again, the Spacelab, the Payloads and the People. This is a site that we have up now in the kind of the, down in the bottom left there is the actual website. Yeah, it's hard to see. That's okay. Yeah, Spacelab, payloadpeople.com. We got this set up. This is for the people who work these missions. Okay, this is a place you can go and sign in, tell us your story. It's also a place for people to go and read about that, all those stories that basically couldn't fit in that book. The book we wrote, you can't fit 20 years of science payloads into a book, into one book. And so the book kind of touches on tip of the iceberg. This site will be used for a lot more detail. This will give you a lot more of the stories that occurred that we couldn't put in the book. And
it's a cool book. It's not that technical. The technical stuff has to be there, and you want to be smart and read and know about stuff like that. We do have this book available in our museum, but you can get it on Amazon. And please use the American Space Museum as your Amazon Smile nonprofit on there. So
there you go.
How are book sales?
Book sales are good. Good. I went digital versions are up to about 1,500 copies. And I don't know about hard copies, how many of these. They'll tell us at the end of the year how many hard copies we sold. But the idea was to get the story out. This the story of the work we did. And this was the good one because this STS-7 OSTA 2 was our very first payload that flew in space for level 4. So we're really proud of that one. Yep.
And how did the experiments work out?
Very good, from what I understand. Yeah, a lot of times we talk to the PIs and they tell us the results of all the hard work. It ended up being, worth it. Sometimes things didn't work, but that was another thing that kind of I wouldn't get upset about. But people would say, well, the experiment failed. Well, no, the process they used failed, but they learned not to do that thing again in space. It didn't work. So you learned everything on every mission, even though maybe the approach didn't work. They still learn maybe not to do that next time. But a lot of times, most of our payloads are very, very successful. Yes, sir.
What were some of the lessons learned that got applied from this first time of using the MPES in a cargo bay?
Installing the trunnions. There's techniques on how to get all those bolts, because the bolts are basically a castellated nut, and the bolt itself has a hole in it. So you got to line the nut up to be able to get the cotter pin. So there is techniques on there that we learned to use. Again, with that yellow structure on handling things, we tried to put wheels on things. We tried to avoid doing crane ops, because crane ops are hazardous operations, require a lot of people. Those are lessons learned on how we can bring these structures in and work on them. Different techniques like the mouse, the offline lab where we had to put the crane into the offline lab area there. We learn now how to modify facility. How can we modify facilities to do something that we hadn't planned on doing? Of course, all the operations at the pad, those were almost brand new. So we learned about the PIGM, we learned about how you install payloads at the pad, how you install them in the orbiter, how you test them. One important thing here too was the OSTA 2, not only mechanically was the trunnions held in the shuttle, of course you had cabling that linked between the payload and the shuttle, so they talk with each other. Well, for this particular payload, we had a big coil of cables wound up because they weren't sure about the length and all this. And so basically we learned that, hey, you don't need to have 15 feet of cable in this thing. Because when we actually connected it up to the orbiter, again, that was one of the things Frank Valdez did, we found there was a lot of leftover cable, so we basically had to tie wrap the cable in place. So things like that. And then, of course, post-flight, bringing it out of the orbiter, taking it back to the operation and checkout building, and the whole orchestra like we talked about, learning how to do things on the fly. You plan things, and then something goes wrong, and your whole schedule goes up in the air, and you start again the next day. So that was a lot of lessons learned. And in the book there, it talks a lot more in detail about the lessons we learned throughout the 20 plus years. Yeah. Yep.
Well, thank you, Mikey. We're learning a lot and hope that you stick with us, as Mikey's going to be coming back in July and every month to talk about a payload. We may even have him back twice a month with some important payloads on there. But appreciate your knowledge and willingness to share it with our Stay Curious fans out there.
Well, thank you,
Mikey.
Mark, for letting
Marty,
us,
we
letting us
have
do
anything
this.
else to say? Any questions, any comments from anybody? Good. Well, okay. Well, thank you very much, sir, for
You're
for
welcome, Mark.
your
Thank
knowledge
you
there.
again, sir, for letting us do
We're
this.
really enjoying this as you keep coming back here. Marty and I learn more, and we can get more involved with some of these payloads. And the astronauts are the astronauts, but the payloads is what the missions were all about.
And we had a
Okay.
huge variety of payloads. And of course, we worked with the astronauts too. So we have a lot of astronaut stories we can tell.
And there's hardly any segment of society that's not been affected today's 2022 world by these 30-year legacy of shuttle payloads.
The payloads basically flew in almost any kind of science you can think of that occurred on the Earth or for space. Payloads flew to be able to get information, learn about, and learn about anything associated: astrophysics, material processing, chemicals, pharmaceuticals, astrophysics. Nebulas, UV, ultraviolet, infrared. You name the spectrum, and the payload basically flew to learn more about that topic. Yes, sir, sure did.
And they may still be analyzing this data harvested 39 years ago. It's particularly the early atmospheric missions laid the bedrock for what's going on in the global warming situation and so forth. So
yeah, we always talk about how many PhDs, how many that came from each of these payloads. All the papers that were done, all the science that was learned, all the things that went on to, and then it would lead on to other things. Some of our telescope missions then leading on to Hubble, onto the Webb telescope. Those are all precursors to some of those elements. Yep.
Well, it's enough to help me stay curious, all right, and want to bring back Mikey. Thank you, buddy.
You're welcome.
Appreciate it.
It's a lot of fun.
And tomorrow we're going to talk about our auction Saturday with Chuck Jeffrey, our collection analyst. You're not going to want to miss that. Chuck talks a lot about some of the individual lots and so forth that are so important to support our museum through these auctions. This is how we keep the doors open. They're our major fundraisers, and we appreciate you getting online and checking that out and bidding and buying some space memorabilia. So enjoy that. And Mikey, Marty, thank you for a great job today. I'm Mark Marquette. We can't wait to see you inside our museum to bridge the space between us.